Let's find some trig function values for these angles that are shown, or that I'm going to draw here. Alright, so let's say I've got this angle here. This is angle theta. And here's the point on a circle. It's not necessarily a unit circle. It's got radius r, so the length of this is r, and I can make that into a reference triangle by extending a perpendicular line to the x-axis like that. So we've got a reference triangle, and let's say this distance here is -4 on the x-axis from the origin to that point there, and let's say this is -3 going down the y-axis. That would be this side. Alright. So this point has coordinates -4, -3. Alright. Now, first of all, we need to determine r. That's the distance from the origin. That would be this distance here, is the distance from the origin to -4, -3. So you can use the distance formula. Alright, so r would be the distance is equal to, well, let's say this just any general point xy. Any general point xy, its distance from the origin 0, 0 would be given by this formula, x minus 0 squared plus y minus 0 squared. And that equals the square root of x squared plus y squared. Alright, so if you have a point xy and you want to know its distance from the origin, you would just plug in the coordinates in this formula. So on this one, r would equal the square root of x squared, that's x is -4 here, plus y squared, that's -3 squared. So that equals the square root of 16 plus 9, which is square root of 25, or 5. So r is equal to 5. Now we can calculate the trig function values. So sine of theta is equal to y over r. What's y? That's the y coordinate on this point, -3. So that's -3 over the radius of the circle, which is 5. And there's sine of theta for you. Alright, and then we have cosine theta is equal to x over r. X is -4 here, and r is 5, so that's -4/5. Well, now that you know cosine and sine, you can get the other trig functions. Tangent is sine over cosine. Secant is 1 over cosine, and sine is, or rather cosecant is 1 over sine. Cotangent is 1 over tangent. So to get 1 over these, you just invert them, flip them over. Alright, so for example, cosecant of theta here would be 1 over sine of theta, or 1 over -3/5, which is -5/3. Just flip that over, and you've got your cosecant. Secant would be flipping this over, -5/4. And you can calculate the tangent by going -3/5 divided by -4/5. Alright? Okay. Now, any point other than the origin on the terminal side of an angle can be used to determine the trig function values of that angle. And the function values are the same regardless of which point is used. And let's take a look at an example of what I've just said. So, let's consider an angle theta in standard position whose terminal side lies on a line, y equals negative 1/2 of x. Alright. So I'll draw this line. It's a line going through the origin. Slope is negative 1/2. Looks something like that. And it forms an angle theta like this. Here's your angle theta. This is y equals negative 1/2 x. And let's pick 2 points on this line. Let's say you've got x is negative 4, y is negative 1/2 of negative 4, which is 2. So you got negative 4, 2. Let's pick another point like x is negative 8, y is 4. And we can calculate sine theta, cosine theta, and so on with both of these points, and you'll see that the trig function values will be the same regardless of which point you use as the forming part of your angle there. So let's take a look at the first point, negative 4, 2. All right. So what's r then? R would be the distance from the origin to that point. So r would equal square root of x squared plus square root of x squared plus y squared. So r would be negative 4 squared plus 2 squared, the square root of that. And that's equal to square root of 20. And that's equal to 2 square root of 5. Alright. Now, what's the sine of theta? Using that point, sine of theta would be y over r. And y here is y equals 2. So that's equal to 2 over 2 square root of 5, which is 1 over square root of 5, which can be rationalized. Just multiply top and bottom by square root of 5. And that rationalizes to square root of 5 over 5. Now what about sine theta for this other point? So that would be negative 8, 4. What's r for that? R is equal to the square root of x squared, that's negative 8 squared, plus y squared, that's 4 squared. And that equals square root of 80, which is 4 square root of 5. So using this value for r, the sine of theta is y over r. Here y is 4, so that's 4 over 4 square root of 5, and you can see this gives us the same value that we got in the other example, or using the other point. So basically this example is telling you that it doesn't matter what point you pick to calculate your sine and cosine and other trig function values, you're going to get the same trig function values. Another way of looking at it would be if you take any right triangle, if they have the same angles in them, let's say that's the same angle theta in both, it doesn't matter what the sizes of these triangles are, you're going to get the same sine and cosine values. So the trig function values depend only on the angle and not on the lengths of these sides. Alright, the trig function values will be all the same. So here's some more examples. Let's say that tan theta is negative 2/3, and theta is in quadrant 2. Alright. What are the other function values, trig function values? Well, draw a picture first. Now, the tangent of theta is defined as y over x. Alright? And this theta is in quadrant 2, so it's in this quadrant. So I'll draw a line here. There's your angle theta. Okay, so, well, y over x is tan theta, and it's negative 2/3. So, well, what's the y then? The y must be 2, and the x must be negative 3, right? Because in this quadrant, x is negative. So, basically, you've got that reference triangle there, and this is positive 2 for the y value, and that's negative 3 for the x value. Alright. Now, what's the length of the radius or the hypotenuse here of this right triangle? Well, that would be, let's call it r is equal to the square root of, using Pythagorean theorem, 2 squared plus negative 3 squared. And that equals square root of 13. So this is square root of 13. Now, you have all the information you need to calculate the trig functions. For example, sine of theta would be y over r, 2 over square root of 13. And we do want to rationalize that, so you multiply by square root of 13 over square root of 13, which equals 1. And so you end up with 2 square root of 13 over 13. So there's sine of theta. Cosine theta would be x over r, and so on. Alright? Alright, now I'm going to have you read example 3 on page 402 and example 4. And let me give you a homework assignment on this, 5.4. Do 1 to 37 odds. And there you go. That's the last of our internet lessons, and I'm looking forward to seeing you guys again very soon. Thanks for your attention. Have a nice day.